In this problem, we're told that human body temperatures are normally distributed with a mean of 98.21 degrees Fahrenheit and standard deviation 0.62 degrees Fahrenheit. So what that means is that if we look at the distribution of healthy individuals, the mean is here at 98.21, and then the standard deviation is 0.62. In Part A, it says that a hospital uses 100.6 degrees Fahrenheit as the lowest temperature considered to be a fever. So we've got 100.6 up here, and the question is, what percentage of normal and healthy people would be considered to have a fever? So the distribution is of healthy people, and we're looking at what percentage of those healthy people have a normal body temperature of above 100.6. So in order to calculate this, we're going to use the normal CDF function in your calculator. And you get to that by pressing second and vars and choosing option number 2. First thing you're going to give is the lower limit, and that's 100.6. Then we need the upper limit. There really is no upper limit. The distribution goes to infinity. So what we use for that is 1E99. And the mean is 98.21, and the standard deviation is 0.62. And when I enter that into the calculator, I get 5.792440275 E negative 5. So this is given in scientific notation. We need to convert that to standard notation, which would be 0.0000579, and so on. And we want to give the percentage to the 2 decimal places. So I'm going to convert this to percent by moving the decimal point over 2 places, and I have 0.01 is what we get when we round that to 2 decimal places. So the percentage would be 0.01%. So not 1%, but 1/100th of 1%. So that's a very small percentage of the population would have a normal body temperature that a hospital would consider to be a fever. So does this indicate that that would be appropriate? Yes, it does, because then you wouldn't get too many false positives. In Part B, it says that physicians want to select a minimum temperature for requiring further medical tests. What should that temperature be if we want only 5% of healthy people to exceed it? So in Part A, we had a very, very small percentage that were in that cutoff range. So now we're going to lower that cutoff. And I'm going to draw a new distribution. Mean is still at 98.21. And we're looking to see what is the cutoff for the top 5%. So we have 5% at the top here, which means 95% on the left-hand side. So I'm going to use the inverse norm because I have a percentage and I want to find out what the cutoff is from that. So I'm going to put in 0.95, and the mean is 98.21, and the standard deviation is 0.62. And when I calculate this, I get, let's see, where did I have that? 99.23 degrees Fahrenheit. And that is the answer for this problem.